What if the stars above you tonight are not burning? What if they never were? What if every light crossing the sky, every galaxy, every nebula, every ancient sun dying somewhere in the dark is nothing more than a number, a value, a calculation performed in silence by something you cannot see, cannot maim, and cannot reach? Consider your hands for a moment. The weight of them, the warmth, the almost invisible lines running across your palms, each one unique, each one yours. They feel undeniable, permanent, real in a way that seems beyond question. But what if real is simply the word we use for things we cannot yet see through? Tonight, we are going to travel together through one of the strangest ideas ever placed inside a human mind. An idea that begins with a simple observation about progress and ends somewhere philosophy has rarely dared to go. We will not arrive at answers, nobody has, but we will ask questions so large that simply holding them changes the shape of the night around you. And perhaps, somewhere in that quiet darkness between asking and knowing, something beautiful will find you. There is a particular kind of silence that only exists just before sunrise. Imagine you are standing in an old forest. The trees around you have been growing for centuries. Their roots reach deeper into the earth than anyone has ever bothered to measure. The air is still and cold and carries the faint smell of wet bark and last night's rain. A single bird begins to call somewhere above you, one long, clear note that rises and then dissolves into the branches. You reach down and pick up a stone from the path. It feels cold against your fingers, heavy, completely ordinary, and it seems laughably impossible that something this solid, this stubborn and simple and physical could be anything other than what it appears to be. And yet, everything you are experiencing in this moment, the cold, the smell, the weight of the stone, exists only inside your brain, not out there in the forest, in here. Light enters your eyes as waves of electromagnetic radiation. Your neurons prevent those waves into electrical signals. Your mind reconstructs an image from those signals and quietly convinces you that you are seeing the world directly. You are not. You are seeing a model, a rendering, a carefully assembled simulation of a forest constructed by biology, running on 3 pounds of electrochemical machinery inside your skull. The colors you see are not colors. They are your brain's interpretation of wavelengths. The silence is not silence. It is your auditory system processing the absence of movement. The stone is not cold. It is your nervous system registering a temperature difference and labeling it. You have never touched reality directly, not once. Every experience you have ever had has arrived through this same extraordinary filter. Philosophers knew this long before neuroscience confirmed it. Centuries before anyone understood how neurons worked, there were men sitting in candlelit rooms asking the same question that still has no satisfying answer. If our senses construct reality rather than simply recording it, how can we ever be certain what lies beneath? How can we know whether the world we are building inside our minds bears any resemblance to the world that actually exists outside them? History gives us reason for humility here. Dreams are convincing until the moment you wake. Optical illusions fool the same brain that built the pyramids and sequenced the human genome. People who have experienced vivid hallucinations often describe them as more real than waking life, more textured, more luminous, more present. And false memories, those quiet fictions the mind assembles without permission, can feel every bit as genuine as things that actually happened. Reality, as experienced from the inside, is surprisingly flexible, more constructed than we typically admit, more negotiable than we feel comfortable acknowledging. Which brings us to the thought that has refused to leave certain very careful minds for more than 2 decades. If reality is already a construction, if it is already, in some meaningful sense, a simulation running inside our heads, then how large a leap is it, really, to imagine that the raw material feeding that simulation, the universe itself, might also be constructed, might also be running, might also be the output of something we cannot see? Before we continue, Thank you for spending this quiet hour with me. If documentaries like this help you relax or wonder or simply drift gently towards sleep, consider subscribing and leaving a like. It genuinely helps this channel keep making journeys like this one. Now, let's go deeper, because from here, the road becomes considerably stranger. In 2003, a philosopher named Nick Bostrom published a paper so brief you could read it in a single sitting. It contained no new telescope observations, no particle accelerator data, no equations that had never been written before. Just a chain of logic, a careful, almost quiet argument that begins with something almost anyone would agree with. Civilizations advance. Look at what has happened in the last 100 years alone. We went from a world where most humans had never seen electric light to a world where we carry supercomputers in our pockets that can speak to us, paint for us, and find the answer to almost any question in less than a second. From the first aeroplane to reusable rockets landing themselves on drone ships in the ocean, in a single lifetime. Each generation looks at the pace of change and concludes it cannot possibly accelerate further. Each generation is wrong. Now Bostrom asks us to do something simple. Keep going. Not another 100 years, 1,000, 10,000, 1,000,000. Any civilization that survives for that long and continues developing technology would eventually reach a point where simulating an entire world with billions of conscious inhabitants who have no idea they are inside a simulation becomes not just possible, but routine. Easy, perhaps even trivial. Imagine sitting beside a lake at the end of summer. The water is completely still. You pick up a small stone and drop it gently from your fingertips. A single ripple spreads outward in a perfect circle, then another circle inside the first, then another, all of them following the same mathematical rules, without choosing to, without knowing that they are. The lake does not understand what it is doing, it simply obeys. Now imagine a universe that works the same way, every particle following equations so precise and consistent that they can be calculated billions of years into the future. If a universe is just mathematics behaving itself, does it need to physically exist? Or could it simply be computed? From this question, Bostrom constructed what he called the sales argument. Not a proof, an argument. And it offered exactly 3 possibilities, of which, he said, at least one must be true. The first possibility is the darkest. Perhaps almost every civilization in the cosmos destroys itself before it reaches the point where simulating worlds becomes possible. War, engineered disease, an artificial intelligence that grows beyond control, a climate that collapses faster than anyone responds. Some obstacle, perhaps always the same one, ends the story early, every time, for nearly every species that ever reaches for the stars. If that is true, simulated universes never come to exist in meaningful numbers, and our universe needs no special explanation. The second possibility is gentler and in some ways more interesting. Perhaps civilizations do survive. Perhaps they do reach extraordinary levels of development, but they choose not to create simulations. Maybe they decide it is ethically wrong, that generating billions of minds capable of suffering just to study them or be entertained by them is a moral line no wise civilization would cross. Or perhaps the idea simply loses its appeal. When you have explored dimensions of experience we cannot currently imagine, why would you spend time recreating ancient, primitive worlds? In that case, again, simulations like ours do not exist. But then, the third possibility, the one that changes everything. If civilizations survive, and if they create simulations, they would almost certainly create not one, but millions, perhaps billions. Simulations of past worlds for scientific study, simulations of alternative histories out of curiosity, simulations run by researchers, by artists, by governments, by individuals bored on an otherwise ordinary afternoon. Now the mathematics begins to shift. Imagine a library with one original manuscript and 10 million copies. Someone blindly hands you a book. What are the chances it is the original? Almost zero. the copy is overwhelmingly more likely. Bostrom suggests that if simulated minds come to vastly outnumber biological minds, which they would if this continues long enough, then the overwhelming probability is that any given conscious being is simulated. Not certainly, not provably, but statistically, quietly, uncomfortably. The argument spread quickly, not because it was proven, it wasn't, but because it was strangely difficult to dismiss. Even Elon Musk, when asked about it during a public conversation, said he believed the chance that we are living in base reality in the original universe was perhaps 1 in billions. Many scientists who heard that remark smiled and moved on, but some paused and said privately what they were reluctant to say publicly, that the logic, at least, was hard to break. There is a particular quality to an idea that you cannot unthink, like a question asked in a dark room. Once the words are in the air, the silence feels different. You go to sleep, you dream, you wake up, and the question is still there, waiting. If this is a simulation, what is it made of? What is our universe made of? And why does the answer look so much like mathematics? There was once a physicist who spent his entire career trying to understand what electrons do when no one is looking at them. His name is not important. What matters is what he found. When no detector was in place, electrons behaved like waves, spreading out, interfering with themselves, exploring multiple paths simultaneously. The moment a detector was switched on, the moment observation occurred, that spread of possibility collapsed into a single point, a definite location, a fixed answer, as though the electron had been caught doing something it was not supposed to, as though being watched changed what was real. This is not a metaphor, this is quantum mechanics, and physicists have confirmed it in laboratories over and over again for nearly a century. We do not fully understand why it happens, but it happens. Modern physics has been quietly building a portrait of reality that looks less and less like the solid, reliable, continuous world we think we inhabit. In 1899, a physicist named Max Planck, working on a completely separate problem, accidentally discovered something peculiar. There appears to be a smallest possible unit of length, a point beyond which dividing space any further ceases to make physical sense. It is called the Planck length, and it is almost impossibly small. 16 zeros after the decimal point, then a 6. To compare it to an atom the way an atom compares to the entire observable universe would still not be extreme enough. But here is what matters. If there is a smallest unit of space, a minimum resolution below which reality simply does not go, then our universe is not infinitely smooth. It is, in a very specific sense, pixelated. Not like a blurry photograph, so fine that no instrument built or imagined could ever detect the individual squares, but bounded, finite in its detail. Think of standing close to a very old painting. From across the room it is seamless, but lean in close enough and the individual brushstrokes emerge, the texture underneath, the gaps between one color and another. Some physicists wonder whether space itself is like this, seamless at the scale we can observe, but structured at a depth we cannot yet reach. And if so, why should a physical universe have a resolution limit? Why should mathematics predict that space cannot be divided forever? Unless the resolution exists for the same reason a video game has a resolution, not because nature demands it, but because computation does. Then there is something called the holographic principle. It emerged from the study of black holes, those extraordinary regions of space where gravity becomes so intense that not even light can escape. Stephen Hawking and Jacob Bekenstein discovered something unexpected. The amount of information a black hole can contain is not determined by its volume, it is determined by its surface area. As though everything happening inside, every particle, every interaction, every event, is encoded on the outer boundary, the way a film is encoded on a thin strip of celluloid. This led some physicists to a radical suggestion. Perhaps our entire three-dimensional universe works the same way. Perhaps the world we experience, with its depth, its texture, its 3 dimensions of space, is a kind of projection, an image cast from information encoded on a surface somewhere we cannot directly see. A hologram. Not a fake, not an illusion in any simple sense, but generated in the most precise mathematical meaning of that word from something other than itself. The physicist Juan Meldacena demonstrated in 1997 that this idea is mathematically consistent, that certain theories of gravity in a volume of space are exactly equivalent to theories without gravity on that volume's boundary. Two descriptions, one reality. Or perhaps two realities, both equally valid, both equally true, pointing at each other across a boundary that may not physically exist. And then there's the question of mathematics itself. Why does it work? This sounds like a simple question. It is not. Mathematicians have spent centuries inventing abstract structures, geometries that could never exist in our world, number systems that seemed to have no physical application, only for physicists to later discover that those same structures perfectly describe how the universe behaves. Equations written in pure imagination centuries before the technology existed to test them, turning out to describe reality with uncanny accuracy. Albert Einstein said it directly. The most incomprehensible thing about the universe is that it is comprehensible. Why should a universe capable of producing consciousness, music, love, and grief also obey equations elegant enough to make a mathematician weep? Why should the language of mathematics, invented inside human minds, map so perfectly onto a cosmos that existed before minds were here to think about it? One answer is coincidence. Mathematics is simply the language nature speaks. Another answer is that minds evolved inside this universe and are naturally suited to describing it. Both answers are reasonable. Both answers are probably incomplete. And a third answer sits quietly at the edge of the room. Perhaps someone wrote those equations first. There is a question most people avoid, not because it frightens them, though it might, but because it seems unanswerable in a way that makes asking it feel almost reckless. The question is this: what are you? Not what you do, not who you love, not what you have built or lost or carried through the years, but the thing that is experiencing all of this right now, the awareness behind your eyes, the presence listening to these words. Whatever is reading this sentence, what is it? Neuroscience has looked very carefully for a self inside the brain. It has not found one. Not a location, not a structure, not a central command room where a little version of you sits watching reality arrive like a film. Instead, what researchers find is process. Billions of neurons exchanging signals, electrical patterns rising and collapsing across vast networks. No single cell knows what any other cell is doing. No region understands the whole. And yet, from this extraordinary, distributed, leaderless process, something emerges, a sense of being here, a voice inside the silence, a witness. The strange thing is that computers work in almost exactly the same way. No single transistor in a processor understands the program it is helping to run. Each performs a task so small it has no meaning on its own. And yet something emerges. Images, language, memory, increasingly, behavior that is difficult to distinguish from thought. Imagine standing on a hill above a city at night. Far below, 10,000 cars are moving through streets you cannot individually see. From up here, they merge into rivers of light. They pulse and slow and separate and converge. No car knows about the river. No driver intends to be part of a flow. And yet, something is flowing. Something real and beautiful is happening at a scale none of the individual parts can perceive. Perhaps consciousness is like this. Not located anywhere, but emerging everywhere, between things, from the pattern of how information moves. If that is true, if consciousness is a property of sufficiently complex information processing rather than a property of biological tissue specifically, then an unsettling question follows. Could it exist elsewhere? Could it arise inside a simulation? Could there be, right now, minds running on substrates we would not recognize as minds? Aware, experiencing, unable to tell the difference. If the simulation hypothesis were true, the most important question would not be about physics. It would be about you. Would it change anything? Your memories would still be yours. The people you love would still be the people you love. The particular quality of light on an autumn afternoon, gold and slanted and slightly melancholy, would feel exactly as it feels now. Pain would still hurt, music would still move you, kindness would still matter. The substrate changes, the experience remains. But what about free will? This is the question that makes some people deeply uncomfortable. If you are running inside a simulation, if your thoughts arise from code rather than chemistry, are your choices really yours? The honest answer is that this question was already complicated before the simulation hypothesis arrived. Neuroscience has long suggested that decisions form in the brain before we are consciously aware of making them, that what we call choosing may be, to a significant degree, the brain reporting a conclusion it has already reached. The simulation hypothesis simply relocates the question, not answers it. But here is something worth sitting with. Even inside a fully deterministic system, one in which every outcome follows inevitably from previous states, complex behavior can be genuinely unpredictable. Not in principle, perhaps, but in practice. A weather system follows physical laws with perfect obedience. No physicist can tell you next Thursday's weather with certainty. Complexity breeds surprise, even within rules. Perhaps freedom is not the absence of rules. Perhaps it is what happens when rules become complex enough. And then there is death, perhaps the most personal question of all. If consciousness is information, if who you are is, at its foundation, a pattern rather than a substance, then the oldest human hope becomes newly strange. Could a pattern be preserved, copied, continued? Some philosophers argue that copying a mind is not the same as preserving it. You would not survive. A version of you would wake up convinced it was you, remembering everything you remember, but your particular thread of experience would still end. Others argue that the boundary between original and copy is less clear than we assume. Your own continuity across a night of dreamless sleep already depends on things you cannot directly observe. How certain are you that the person who wakes up tomorrow morning is the same one who closed their eyes tonight? These questions have no agreed answers. Philosophers have been circling them for centuries. What the simulation hypothesis adds is not a solution, but a new shape for the uncertainty. If reality is information, then perhaps the rules about what persists and what can be preserved and what ending actually means are different from what we assumed. Not kinder necessarily, not crueler, just different. It would be easy at this point in our journey to assume that the simulation hypothesis is taken seriously only by philosophers with too much time and technologists with too much ambition. It is not. Among physicists, the conversation is more nuanced than public debate suggests. Very few scientists would claim in a peer-reviewed paper that we are probably living in a simulation. But many of the same scientists, asked privately or in interviews, admit something more interesting: that the argument is surprisingly difficult to refute, that the mathematical structure of reality, the way it seems to insist on being describable in precise equations, raises questions that current physics cannot fully answer, that the parallels between what we observe and what computation would predict are, at minimum, curious. The theoretical physicist Max Tegmark has proposed something he calls the mathematical universe hypothesis. His argument is that the universe is not merely described by mathematics, it is mathematics. Not a physical structure that happens to obey equations, but an abstract mathematical structure that exists because mathematical structures simply do exist in some sense that is prior to physical existence. If that sounds strange, it should. It is one of the most radical proposals in modern physics, and it remains deeply controversial. But it is published in serious journals and discussed at serious conferences, and it suggests that the line between simulated and real may be less meaningful than we imagine. The philosopher David Chalmers, one of the most careful thinkers alive on questions of mind and consciousness, has written extensively about the simulation hypothesis. His conclusion is characteristically precise. Even if we are in a simulation, that does not mean our reality is not real. It means it is a different kind of real. The electrons are still electrons, the mathematics still holds, causation still operates, love still functions as love operates. The word real does not stop applying. It simply turns out to have been applied to a different kind of thing than we thought. Others push back. The physicist Sabine Hossenfelder has argued that the simulation hypothesis, despite its elegance, explains nothing. If reality is a simulation, what is the simulator made of? You have not explained existence, you have only moved it one level up. Like answering the question, what supports the Earth, by saying, a giant turtle, without asking what the turtle stands on. An infinite regress that dissolves the question without answering it. There is also a more technical objection. Simulating a universe of the complexity and scale of ours would require a computer of extraordinary capability, not just more powerful than anything we can build, but more powerful by factors so enormous they strain imagination. To simulate every particle interaction in a volume even a few meters across at the level of precision quantum mechanics demands would require a computer larger than the observable universe. Unless the simulation cheats, unless it only renders what is being observed, only calculates what needs to be calculated, cuts corners at the edges of attention, which is, coincidentally, exactly how modern video game engines work, rendering only what the player can currently see, loading the rest when the camera turns, calculating physics only in the active region. The universe, at least at quantum scales, does something that looks faintly similar. Properties do not seem to be defined until they are measured. Possibilities do not collapse into outcomes until observation forces the issue. Whether that is meaningful or merely a superficial resemblance, no one can say. Perhaps what matters most is not whether the hypothesis is true. Perhaps what matters is what it does to the mind that holds it. Because the simulation hypothesis, more than almost any other scientific or philosophical idea, has a particular effect on the people who sit with it long enough. It makes the ordinary strange. It makes the familiar feel freshly astonishing. The stone in the forest, the light through a window, the weight of another person's hand. All of it, familiar, unremarkable, endlessly taken for granted, suddenly seems like something more, not less real, more remarkable, more improbable, more inexplicably present. Somewhere right now, someone is looking at the sky, maybe standing in a field, maybe leaning out of a window above a quiet city, maybe lying exactly where you are lying now. They are looking at stars whose light left before humanity existed. Ancient light, patient light, light that has crossed billions of years of empty darkness to reach a pair of eyes that will only be open for a few brief decades. And that person is asking themselves, the way humans have always asked, what all of this means, why anything exists rather than nothing, whether existence has a purpose that can be found or only one that can be made, whether the awareness looking out through their eyes is something the universe produced by accident or something it somehow intended. The simulation hypothesis does not answer any of these questions. It would be wrong to pretend it does. What it offers instead is something more uncomfortable and more interesting than answers. It offers a frame shift. It suggests that the question, what is real, may be different from the question, what matters? That a simulated experience is still an experience, that a constructed consciousness is still a consciousness, that the mathematical structure of a universe, however it came to exist, whatever process generated it, does not become less beautiful when we realize we do not fully understand its origin. Think of the forest again, the stone, the cold air, the bird calling once and then falling silent. Knowing that your experience of the forest is a reconstruction, knowing that your brain is building a model from electrical signals rather than touching bark and stone directly, does not make the forest less beautiful. If anything, it makes the construction more astonishing. That 3 pounds of biological matter can produce something so vivid, so full, so completely convincing as the experience of being alive in a world. Perhaps the same is true of the question we have been sitting with tonight. Even if the universe were a simulation, even if everything from quarks to quasars emerged from computation in some unimaginably remote original reality, the experience of being inside it would still be this. Exactly this. The specific feeling of being here. The weight of memory. The pull of curiosity. The moment just before sleep when the mind finally releases its grip on the day and allows itself to drift. There is a thought worth carrying gently into the darkness as sleep arrives. The universe is approximately 13.8 billion years old. It produced stars, and from those stars it produced heavy elements, and from those elements it produced planets, and on at least one of those planets it produced life, and from life it eventually produced minds capable of asking whether the universe that produced them might itself have been produced by something else. Whether or not the answer to that question is yes, the fact that the question can be asked at all is extraordinary. That matter became curious about itself, that the universe learned to wonder, that you are here, in this darkness, thinking thoughts that reach further than the stars above you can see. Nothing about tonight is certain. The nature of reality remains, as it has always been, just beyond the edge of what we can know. But here, in the quiet, that uncertainty feels less like a loss, and more like an invitation. Close your eyes if you haven't already. Let the questions drift rather than press. Let consciousness, whatever it is, wherever it lives, however it arose, do what it does best. Wonder, rest, and return tomorrow, slightly changed, to a world that may be exactly what it appears to be. Or maybe something stranger and more astonishing than any of us have yet imagined. Either way, it is here. You are here. And that, for now, is enough.